everyone, welcome to my channel. So this is a video belongs to characteristics of common emitter connection. So already we know that in the practical session through common emitter configuration. So like this structure only we are going to use. Instead of common emitter configuration circuit, just the same connection here, but here what we did, we just added the ampere meter and a voltage meter. Okay, so already we know that ampere is going to connected in the series terminal of this area microampere. So practically we are going to connect it in a mere milliampere, and then voltage circuits, and then voltage. This area is belongs to input. This area is belongs to input. This area is belongs to output. Okay, so that means in the input it has some characteristics. What we are going to give input, we are going to take output. So output it has some another characteristics. So that characteristics called as input and output characteristics. Okay. So now we will see the what is meant by input, what is meant by output characteristics. So in the input characteristics, the curve we are going to draw. See there in the circuits itself, we can know that this is the common emitter configuration. Okay. So this is for collector IC. This is for IE. This is for IB. Generally, common emitter circuits for normal transistor. Input means already I told you this is for input IB and IE. So that's why here we mention input curve between IB and VBE. So input curve between IB and VBE. So in between this voltage is called as VBE. In between this voltage is called as VBE. See here IB and VBE. So these diagrams are very important. Microampere, IB and VBE. So in between this value is called as IB and VBE. So here, so this is circuits. I can use here IB, here VBE. Okay, the input circuits are depends upon like linear characteristics. The input will come like this. If you increase V, the current will increase automatically. We can keep it here the milliampere constant value. If you kept here 5 ampere, if you kept here 5 ampere, the current will increase, the voltage will increase, the current will increase automatically. That's why we kept it here like VCE, we need to keep constant value. So here we need to keep constant value. This VCE is constant in the input circuit. VCE is constant. Then if you change the VBE, IB also will increase. If you change the VBE, I was say, see here, the input characteristics of common emitter connection determined in the circuit shown in figure. Keeping VCE is constant, up to, for example, 10 volts, and base current varies, values are VBE. So VBE varying, IB also increasing, the time of VCE is constant, the plot. So you can look this graph. Okay, you can look this graph, and these informations are very important while writing the examination also. These points also very important. Okay, so see here VCE kept 10 volt, VCE 1 volt, the voltage will like this, VCE 10 volt like this. So again we can keep VCE equal to 15 volt. So VCE equal to 15 volt. Already we did in the laboratory same thing. Okay, then the characteristics resemble of forward bias diode curve. So if you know the diode characteristics, this is the forward bias, this is the reverse bias. So these curves look like as forward bias of the normal diode circuit. Understand? Normal diode circuit as compared to common base configuration we didn't learn now. So rapidly increase. Compared to other configuration, this is rapidly increase. So in how to calculate the input resistance. So this is the formula for input resistance. That small Ri del VBE del IB at constant of VCE. So this constant of VCE we are going to calculate the input resistance. The same thing in the output characteristics we are going to take curve from IC equal to IC and VCE. Now here I think VB is constant. See here IB is constant. So this is the output characteristics VCE and IC. If you increase the value, so particular place. After that, this is called one area. That area is called as knee voltage. Look like as one saturation going to happen. After that, if you increase, it will not increase. That's why it is called knee operation, knee voltage. This way. So for example, here 1 volt. See that all the value around this area is around maximum 1 volt. For 5 ampere also, IB equal to 5 ampere, 10 ampere, microampere, 20 microampere, the knee voltage is 1 volt. It is also very important. Keeping the base current, IB is fixed. See that IB is fixed like 5 microampere, and then if you change the IB value like 10 microampere, IB value like 10 microampere. So IB is fixing, varying the VCE. So obtain the new characteristics, then repeated the value and varying the VCE. So you see here varies the values of VCE. Note the collector current of ICE. The ICE is increasing rapidly. This is called output characteristics of common emitter configuration. Okay, so in the output characteristics, almost independent value of the VCE. Okay, the collector current IC is varies with the VCE between 0 and V only. So see here, the collector current is varying only this area. After that, there is no collector current variation. After that, it's saturated. That's why I mentioned here IC is varies only VCE between 0 and 1. Those values are very important. After this, collector current almost independent of the VCE. If you increase also, it will not change. Saturated. The following steps are very important. Then another steps. Knee voltage. The transistor always operated in the region above knee voltage. That's why it is called as a operation voltage of operating point of transistor. So how to calculate the output resistance? Output resistance is called as R0 del VCE by del IC. Output resistance in the order of 50 kilo ohms. Output resistance in the order of 50 kilo ohms. This all the values are very important. Okay, output resistance in the order of 50 kilo ohms. The same thing, input resistance also the few hundred kilo ohms. See that few hundreds only, few hundred ohms. So input resistance value, output resistance value, knee voltage, input characteristics curve, output characteristics curve. These terms are very important for your examination purpose. And also for your competitive examination, they will ask a different activity of based on the input resistance and also output resistance. Okay, thank you my dear friends and students. We will see in the next update video, surely with the help of some solved problems, how to operate with the common base, common collector and the common emitter. Thank you once again. Thank you all.